May 19th. It's great that you could join me here. Grab a coffee and let's get smarter together. I had the most lovely day yesterday with long-time online friends who turned real-life friends now. We pulsated in the same frequency. To prove my point, we even shortly talked about what I'm doing here. It made me realize that I should revisit how the plethora of data is collected that we choose but a sliver from to generate our models of the world and the self. The data we must constantly revisit so our metabolic and timely restraints don't mulct us of the kind of playoff that's only available via random search. The origin of any multicell organism was a single cell. And once unified in a multicell organism, the cells, whilst they do specialized work, don't lose the abilities of a single cell. They remain individual reinforcement learning agents, single cell organisms that try to survive by cooperating with their environment, from which they get most of their rewards. That means every cell in our body has the ability to send multiple message types and receive multiple message types, to do so conditionally and to learn under which conditions to do it and how to modulate it. As a result, every cell in our body can in principle function like a neuron because it fulfills the same learning information processing tasks. The main difference that exists between any other cell and a neuron is that any other cell can't communicate over long distances. They are mostly talking to each other, the other cells that are directly adjacent. That's basically true for neurons as well. Just that neurons have axons, and these tentacles reach very far from through the organism. Along the axons, very specific messages are sent at high speed that are encoded in extremely short, high-energy bursts. So you can imagine the every cell communication as snail mail, while the neural network is the email system. What's important to realize, though, is snail mail or email, the gazillion of messages moving around at all times all contain information. And when you put the information of either system together, one picture forms, a model of a world limited to what can be measured by us. But the picture of a high-speed neural network will differ from the picture of the slower every cell system. Why? Because neurons need a lot of energy to operate. The brain alone, in resting state, accounts for 20% of our energy consumption, despite only representing 2% of our body weight. So we can't have an unlimited number of neurons operating in our body. This means the high speed necessary for us to have enough information available to pursue immediate goals and survive is bound with a reduction of the information density available to generate the model of the world. So the model generated via the high-speed neural system is far less pixelated, so to speak, than the model of the world generated at every moment by the slower every cell system. Since we want the best of both systems, the high-speed system must be rewarded for every switch it does in the selection of the data that it runs along its axons, a body's version of net neutrality in a way. This reward is the dopamine, released when we find environmental triggers sparking a switch. For that, we need to be able to realize a trigger is a trigger and one trigger is different from another, whose different triggers feel different. Exactly like the different cocktail of information now running along the axons. You want more dopamine? Go on trigger hunt. Explore, as known as think. Make a habit out of thinking. Let's turn thinking into a movement. Like, comment, share, and follow lest you miss a single opportunity to improve yourself and society. And when you do, we'll meet again at the coffee pot.